Good morning. This is your Stats Sensei, Mr. Spensei, and this is going to be the pre-quiz covering the normal, inverse norm, and central limit theorem. So, the population mean and standard deviation for the hours worked per week by part-time college students are mean of 25 and standard deviation of 6. Suppose that a random sample of 81 part-time students is selected from the population. So let's mark this down. We have a mu equal to 25, a standard deviation equal to 6, and we have a sample size of 81. Draw a graph illustrating the empirical rule for the distribution of hours worked. Okay, this is important. This is hours worked. This is not average. It doesn't say anything about the average. And since it doesn't say anything about the average, I really don't even care about the sample size in this case. These will be the values we're working with. Clearly labeled as z-scores and actual values. You must show the standard deviation graph on the answer document. All right. So in this case, this should be pretty easy. So we're going to start off with our z-scores because that's the easy part, because z-scores start off at 0. So here's our mean: 0, 1, 2, 3, and then -1, -2, -3. And of course, this goes to positive infinity, and this goes to negative infinity. And I'm going to label this as my z-scores. All right. So there we go. We have the first part. We also need to show the percentages, because we're illustrating the empirical rule. So this right here is 68%. Right here, we're coming up and we're going, okay, straight across. Plus or minus 2 is 95%. And then plus or minus 3 is 99.7%. All right, so we got the first part done. Now, we also need to talk about the standard deviation. Well, so we need to talk about the actual values. All right, our actual value, our actual mean is going to be 25, and our standard deviation is 6. And by the way, I'm just going to make a note up here. Z-scores. Z-scores, mean equals 0, standard deviation equals 1. But our actual values, we have a 25 and 6. So we're basically going to be changing by 6 each time we go up and changing by 6 each time we go down. So 25 plus 6, 31, 31 plus 6, 37, 37 plus 6, 43. Going the other way, 25 minus 6 is 19, 19 minus 6 is 13, 13 minus 6 is 7. All right, so our actual values I did in red. Okay, next thing. So that takes care of question 1. Question 2, 82% of the students will work within what interval of hours centered about the mean? All right, so first off, they gave me a percent. If they give me a percent, that lets me know that I'm working with an inverse norm if we have a normal population, and they already told us we have we have a normal population, and they also told us up above that our mean is 25 and our standard deviation is 6. So we can continue with that information, and we're going to draw a picture of this, and it says centered. So I need to draw a normal curve. Well, we're centered at 25. That's our mean. And since it's centered, we're going to have a lower and an upper. And I'm looking for this information right here. So we're going to look for this lower bound and this upper bound. And we know that it said 82%. So this area right here needs to be 0.82. And please remember that's 82 divided by 100. Anytime you want to do a percent, divide it by 100. So I need to show my calculator commands. So besides showing the graph labeled out like this, I need my calculator commands. And I'm going to go inverse norm. And let's just see what the calculator asked for. So second vars, inverse norm. Oh, the first thing it asked for the area, the mean, and standard deviation. Well, remember that's our PMS. That's our probability of 0.82. Mean is 25. And we just said earlier, our standard deviation is 6. So this is P, M, and then S, our standard deviation. So I'm going to go ahead and plug that into the calculator. 0.82, oops, 0.82, 25, and 6. And it said we wanted centered, so I need to make sure that I have centered, and I need to write that off to the side as well. Center. All right, so now I have everything off my calculator screen. And because I have a lower and upper, I have two numbers. And those two numbers are 16.9554 with an upper bound of 33.0445. Oh, 445. Put those in parentheses. That's our answer. And we're going to label this lower and upper. All right. Part C. And I know this says 3, but this is going to be part C. Give the mean of the sampling distribution of the mean hours worked and give the standard deviation of the sampling distribution. All right. So here, this is tricky. All right. So they're asking for the mean of the sampling distribution. Well, the mean equals the mean of X bar, and we're looking for the mean of X bar. Well, the mean is the mean is the mean, so that part should be a give me. It's 25. On the sampling distribution, we have to do a little bit more work. All right, because that's the standard deviation of the sampling distribution of the mean. So they're asking about the mean, and that's the key word. So we're looking for the standard deviation of X bar, which equals the standard deviation of the population divided by the square root of n. Well, the standard deviation of the population was 6 divided by the square root of 25, which is the same as saying 6 over 5. Well, when I take my calculator and go 6 divided by 5, I end up getting 1.2. So the standard deviation of X bar equals 1.2. All right. Moving on. What is the probability that a randomly selected student works between 27 and 31 hours? A means we're looking for 1. All right. The fact that I'm looking for 1 means this is a normal CDF. All right. So we're going to go ahead and draw our picture. Once again, we're still working with a mean of 25 and a standard deviation of 6. So that hasn't changed. So let's draw our picture. 27 and 33. Well, 25 is right here. Well, 27 is above it, and so is 33. So I'm looking for this shaded area right there. So because we're looking for a single value and it's normal, we're going to use a norm CDF. And you probably remember LUMO, lower, upper, mean, and standard deviation. Lower, upper, mean, and standard deviation. Now, if you forgot that, the calculator will give it to you. So go back to second vars, normal CDF, lower. Oh, my lower bound, 27. My upper bound, 33. My mean was 25, and we already said our standard deviation was 6. So let's plug that in. All right, before I get my answer, I'm going to go ahead and write down my calculator commands before I forget, so I get all my points. So 27, 33, 25, and 6. I'm going to press enter a couple times, and I end up getting 0.2782. I'm going to go ahead and box that answer. We're good to go. All right, the next one. What is the probability that the average number of hours worked per week by a sample of 81 students is greater than 24? Well, hold on just a moment. We got some things here that are interesting. First off, we're still working with the same mean of 25. We're still working with the same standard deviation equal to 6. But now we have a sample size. We have that sample size of 81, and they're asking for the average. Because they're asking for the average and we have a sample size not of 1, we're going to have to use a z-test. All right? And we're looking for the average, which means we're looking for X bar. All right? So let's go ahead and let's draw this out, and then we're going to try to figure out what we actually need. So our picture is going to look something like this. We have a mean. Our mean is still 25. But they said is greater than 24. Well, 24 is down here below it, but they said greater than, so we're shading up. All right? So we're looking for the probability that X bar, please remember it's X bar, is greater than 24. And I'll tell you how to remember that it's X bar in just a second. My formula is Z equals X bar minus mu over sigma divided by the square root of N. The fact that it has an X bar lets me know that. All right. So that's how I know that that's an X bar. Well, where do I go in the calculator when it's an X bar? I go to z-test. So I need to write that down. Z-test. All right. So what does the calculator ask me for? Because we're going to go in order of what it asked for. Stat, test, z-test. Well, the first thing it asked for is the mean. Okay, well, that's easy. The mean was 25. The next thing it asked for is the standard deviation. Well, that's easy. The standard deviation is 11.25. The next thing it asked for is X bar. Well, we just said X bar was 24, and that's what we showed on the graph. And then it asked for our sample size, and our sample size is, oh, wait a second. I made a mistake here. I'm writing down the wrong numbers. I'm looking at something old. Mean is 25. Our standard deviation, we said, was 6. X bar is 24. And we were told that our sample size is 81. I need to see all that information, and I need to see one other thing. I need to see that it's a greater than. All right. So once we have that, 81, make sure it says greater than, calculate, and I end up getting, and this is what I write for my answer, the probability that Z is greater than negative 1.5 equals 0.9331. All right, there's a lot of information to put in that box. All right, so that takes care of number 5. Number 6, what's the probability that the average number of hours worked is less than 23? All right, but now we have a sample size of 20. So once again, our mean is still 25. Our standard deviation is still 6. N is 25 in this case. They're saying average, and we have an N greater than 1. So this means I'm looking for my X bar, which means I need to go to a z-test. All right. So drawing my picture. Well, we know the mean is 25. And we want to be less than 23. So I'm looking for 23, which is down here, and I'm shading to the left. All right. So my probability statement is the probability that X bar is less than 23. This is a z-test. We go to the calculator to get the order. Stat test z-test. First thing it asks for is the mean. So our mean is 25. The next thing it asks for is our standard deviation. Our standard deviation is 6. The next thing it asks for is our X bar. All right, so I need to change my X bar to 23. And then I have an N equal to 81. And I need to make sure that we have a less than because we shaded to the left. So we put our less than and we calculate and we get the probability that Z is less than -3 equals 0.0013. All right, the probability of Z, and this is the part we're really looking for. That part right there, 0.0013. I'm going to change that into a 4, just to get rid of any confusion. Okay. Okay, number 7. What are the z-scores associated with the middle 92%? That's interesting because remember, all z-scores have a mean equal to 0 and a standard deviation equal to 1. So we really don't even need the rest of the problem. So when I draw this, the mean is 0, and I'm looking for this lower and this upper, and this area right here needs to be 0.92. And remember, it's looking for the middle 92%, so this is the way it needs to be drawn. Well, anytime they give you a percent, that also tells me I'm going to a inverse norm. So I'm going to go inverse norm and remind myself, second vars, inverse norm, and it's going to be my PMS. Oh, it asks for my area, my mean, and my standard deviation. My area or probability is 0.92. My mean for all z-scores is 0. My standard deviation is 1. And remember, this is PMS. All right, so let's load that into the calculator. So area 0.92, mean is 0, standard deviation of 1. We need it centered. I need to write that down because it is a centered value as opposed to left or right. And I end up getting two values, my lower and my upper, and I get negative 1.7506. And I also get 1.7506. This becomes my lower bound, which I need to label, and this is my upper bound. And I know that 92% of the data are between those two values. All right, continuing on. A survey is planned to determine the mean monthly transportation cost for employees in a large corporation. The population transportation cost is 400. All right. And it should say mean. The population mean transportation cost is 400. And I'm going to head and write the word mean in there because it should be there. So mu equals 400. And they tell me it has a standard deviation of the population equal to 85. Suppose a simple random sample of 200 employees is taken. So, okay, we have n equal to 200. Give the mean transportation cost of the sampling distribution of the means. All right, so we're looking for the mean of X bar. Well, the nice thing about the mean is the mean is the mean. So we really don't have a whole lot of work to do on this one. So with this being the mean is the mean is the mean, we can say the mean equals the mean of X bar, which in this case is 400. Simple, easy, easy, easy. The next thing, give the standard deviation of the sampling distribution of the means. This is not of the population, but this is of the means. So that means we're going to have to use the standard deviation of X bar, which is the standard deviation of the population divided by the square root of n, which in our case, the standard deviation was 85. And our sample size is the square root of 200. All right. So 85 divided by 200, and I'm just going to raise that to the half power, and I get 6.0104. So the standard deviation of X bar equals 6.0104. All right. Moving on to number 9. What z-score is associated with the bottom 8%? Well, this is asking for z-scores, and all z-scores have a mean equal to 0, standard deviation equal to 1. I really didn't even need that other information. So, first thing, let's draw a picture. Well, I start to draw a picture, and I go, wait a second, got a couple issues here. 8%, that tells me I'm going to inverse norm. That's good. But anytime they give you a percentage in a bottom or top, go ahead and put an X. Well, is that 8% below it or above it? Well, in this case, it says bottom, so the 8% is going to be below, so that's going to be 0.08. And remember, that's 8 divided by 100. All right, don't mess up that. Don't get that wrong because you use the 80%. It's 8 divided by 100, which gives you 0.08. Well, my mean is 0. And this is 8% right here, 0.08 or 8%, however you want to write it. And please don't forget it goes to negative infinity. All right. So my calculator commands inverse norm, inverse norm. The calculator is going to ask me for my PMS, my probability, my mean, and my standard deviation. Well, my probability in this case is 0.08. My mean is 0. My standard deviation is 1. And we're shaded from the left. So we're going to need to write the word left as well to make sure that we choose the right thing. So when we do that, second vars, inverse norm, we're going to put in 0.08, mean is 0, standard deviation 1, and we're choosing left. And we paste and we get a z-score, because that's what we're looking for. Z equals negative 1.4050. And it makes sense that we'd have a negative z-score because we are below the mean. Being the below zero is going to give us a negative, and so sure enough, we have a negative z-score. All right, number 10. What is the probability that a sample of 60 workers, so now we have a sample size of 60, has a mean, that means we're looking for an X bar. This tells me I'm probably looking for a z-test. And then I want the probability that X bar is less than 375. And remember, up above, they told us our mean was 400 and our standard deviation is 85. I'm going to write that down. Mean of 400, standard deviation equal to 85. All right, let's draw a picture of what we have here. So what we have here is we're normally distributed with a mean of 400. All right, our X bar is 375. And it says less than, so that means I'm shading to the left. All right, so our probability statement is a probability that X bar is less than 375. We want a z-test. Let's see what the calculator asked for in the order it asked for. Stat test, z-test, mean. All right, well, we know the mean is 400. The next thing it asked for is the standard deviation. We know the standard deviation is 85. Then it asks for our X bar. Well, we have that right there. That's 375. And it asks for our sample size. and they told me we had a sample of size 60. And please don't forget, we are shading to the left. So give me just a moment as I type that in. 400, standard deviation 85, N 375. Oh, um, excuse me, standard deviation X bar 375, N is 60. I have less than already selected. So the probability that Z is less than negative 2.2782 equals 0.0113. Always box your answers. Okay. All right. Number 11. What's the probability that an employee's transportation costs exceed $500? Well, that's talking about one. So if we're only talking about one, we're going to use a norm CDF. All right. So in this case, we're going to draw our picture. We have a mean of 400, and we're looking for 500, and we're shading up, and this is X. So we want the probability that X is greater than 500. That's what we're looking for. So norm CDF. And most of you have learned your LUMO by now. Lower, upper, mean, standard deviation. Lower, upper, mean, and standard deviation, excuse me. I was writing infinity because I was thinking, oop, I need to write an infinity sign because we're shading up to infinity. So my lower bound is 500. My upper bound is positive infinity. My mean is 400. And the standard deviation is the 85 that they gave us earlier in the problem. So, second vars, normal CDF, lower bound 500, upper bound 9 raised to the 99th because that's the largest value the calculator will take, mean of 400, standard deviation of 85, and we end up getting 0.1197. All right, takes care of that one. Moving right along to number 12. 10% of transportation costs will be below what value? All right. They're giving us a percentage. That tells me we're looking for an inverse norm. So I'm going to draw my picture, but they're not asking for a z-score, so I have to use my actual values. Well, my actual mean was 400, and my actual standard deviation was 85. They gave us that to us earlier. So I'm going to go ahead and put that 400. Now the tricky part. 10% will be below what value? So I'm going to draw my 10%. And well, I'll start with the X. I should have started with the X. So X and the 10% they tell me is below it. Now, please don't forget, divide that by 100. When I do that, I'm finding that I'm looking for this area right here in a 0.10, and I'm looking for an X. So inverse norm. And don't forget, we're looking for PMS. Our probability, well, our probability is 0.10. Our mean, 400. Our standard deviation was 85. And once again, this is our PMS. Probability or percent. Our mean and our standard deviation or our S. So PMS. Let's plug that into the calculator. Second vars, inverse norm, area 0.10, mean 400, standard deviation 0.85, and we shaded from the left, so we need to write that down. Left. And we end up with 398.9106. 398.9106 is our answer, and we'll box that in. All right, moving up to number 13. Suppose 70% of all transportation costs will be above what value? All right, they gave me a percentage, so that means it's inverse norm. They tell me it's above. We already know that the mean is 400 and the standard deviation is 85. So let's go ahead and draw our picture. Now, this one can be a little bit tricky. Once again, our mean is 400. All right. We're going to draw an X, but they're telling us the 70% is above it. So 70 is up here. Please don't forget to divide that by 100. Well, 400 marks 50%. So we're going to start from, we're above it. So we have to shade this way, but I have to go over halfway because I have to have 70%. Right? So this area right here is 0.70, and I'm looking for that X value. All right? So when I plug in, we know it's an inverse norm. It's going to ask us for our PMS, which is 0.70, mean of 400, standard deviation will be the 85 that we already have. And if you look, we shaded from the right. Second vars, inverse norm. The area 0.7, the mean 400, the standard deviation 85, shading from the right. And we end up with 355.425. 355.4259. We need to box that in. And actually, this is three in dollars. So we could put a dollar sign by it, and that'd be pretty good. I need to go back and look at problem 12. I think we have a typo in there. I just discovered. Second vars, inverse norm. Area, 0.1. We have that. Mean of 400. Standard deviation, 85. And we shaded from the left. I accidentally had 0.85. So I need to make a change. And this value right here is going to change to 291.068. Let me check that one more time. So second vars, inverse norm, area, 0.1, mean, 400, standard deviation, 85, shading from the left. Awesome. All right, looking at number 14, last problem. Draw a graph illustrating the empirical rule for the sampling distribution of the mean. All right, this is not looking for actual values. This is looking for the mean and standard deviation of the X bar. So the mean equals the mean of X bar, which equals 400. The standard deviation of X bar equals the standard deviation divided by the square root of n, which in this case is the standard deviation of the population is 85. So this is going to be, and our sample size in this case, we're going to change it. It doesn't say it here. We're going to say that our sample size is 25. We're going to make a sample size of 25. It'll show it on your assignment. So in this case, the standard deviation X bar will be 85 divided by the square root of 25. All right. So first off, Let's do the easy part. The easy part is the z-scores. We should completely know this by now. We should be able to crank that out without even really thinking about it. So the mean of a z-score is 0. All z-scores 0, 1, 2, 3. I'm going to go ahead and make a note. Z-score. Mean equals 0. Standard deviation equals 1. And it goes to positive infinity. This is going to be -1, -2, -3, and go to negative infinity. And 68%, 95%, and 99.7%. Scratch that out. 99.7%. All right. Well, the mean is the mean is the mean, so that's easy. And they told us earlier our transportation costs had a mean of 400. So the mean of X bar equals 400. The standard deviation of X bar equals the standard equals 400 divided by, equals 85 divided by the square root of 25. Well, let's take our calculator and do that real quickly. 85 divided by 5 raised to the half power, 85 divided by 25 raised to the half power gives me 17. So the standard deviation of X bar equals 17. So that means each one of these, when we get to the actual values, is changing by 17. So this first one will be 417. This will be 434. This will be 451. Subtracting 17. This becomes 383. We're going to take away another 17 and get to 366. And we're going to take another 17 and we'll get to 349. All right. I hope this helps you out. Please study this. Your quiz will be similar to this, as will your test. Thanks for watching, and I hope to see you on the next one. Bye.